This is Dr. Esperanza, and if this is your first time to see my channel, I show videos of mathematics from algebra up until calculus, and for this particular series of videos I'm creating, I'll be giving a workshop on lessons from linear equation all the way to differential equations. So stick around and be with my students, and I'm going to give you a workshop on solving quadratics. Alright, good morning. So for today's workshop, we're going to be working on quadratics. So we're going to be working on graphing, factoring, completing the square, and using the quadratic formula. And at the end of this workshop, you'll be able to understand when is the best way to use factoring or completing the square or quadratic formula in solving quadratic equation. And we're going to start with graphing, because by graphing you'll be able to understand the rationale behind the mathematics or the algebra work that you're using in solving quadratic equation. Alright, so quadratic equations obviously has x in it, has numbers in it, but a quadratic equation has a special characteristic, and you need to be able to identify it by just looking at it. Without solving it, and knowing that it's already a quadratic equation is a skill on its own. So let's identify some quadratic equations, because it can come in many forms and sizes. So this one is an example of a quadratic equation, which is the usual quadratic equation that we normally solve. X squared plus 7x plus 12. And the reason why this is a quadratic equation is because the highest exponent in your quadratic equation or quadratic expression is 2. This is another example of a quadratic expression. Why? Because it satisfies the basic condition of a quadratic equation, which is it needs to have a highest exponent of 2. No matter how long or short your quadratic equation, if it has a highest exponent of 2, then it is a quadratic equation. This one is another quadratic equation because, again, you're seeing a pattern, and that is the pattern that you need to understand about quadratic equation. It needs to have a highest exponent of 2. Now, number 4 can be a little bit weird, but it's still considered to be a quadratic equation. Even though you're not seeing the exponent of 2 on problem number 4. Why do you think that it's still a quadratic equation?
FOIL method.
FOIL method? Because if you simplify it and multiply it, it will become a quadratic equation. And that is true, because without even completing the FOIL method, by just multiplying this 2 right here, x times x is already, and now you produce a square. Because in algebra, as I've mentioned, recognizing all those x's and all those conditions is extremely important. Sometimes it's explicit. Sometimes you need to do a little bit of mathematics to produce it. So all 4 of them are examples of quadratic equations. Now, what are the counterexamples of quadratic equations, so that you know when it is a quadratic and when it's not a quadratic? Why is this not a quadratic equation?
Because it doesn't have the highest exponent of 2.
Yes. Thank you, Kiani. There's no exponent of 2. So this is a linear equation. So this is another special case of an algebraic expression or equation. So if your highest exponent is 1, it's not quadratic, but we have a special name to it, and it's a linear equation. And this one, why is it not a quadratic? Because it's over 2, and the exponent is 3, or the highest exponent is 3 on example number 2. And we call this a cubic equation, a cubic function, a cubic expression, because you have a highest exponent of 3. What about this one? Because of the exponent of 4. And do you know the special name we tag an equation with the highest exponent of 4? So highest exponent of 1, linear. Highest exponent of 2, quadratic. Highest exponent of 3, cubic. What about highest exponent of 4? Tick. We call it a 4th degree polynomial. So anything higher than 4 or 3, anything higher than 4, it's going to be 4th degree, 5th degree, 7th degree, 28th degree polynomial. So the only special names that we have for functions would be quadratic, linear, and cubic. So those are the common nicknames that we give our equation. So now that you know your quadratic equation and how it looks like in algebraic form. Quadratic equations, of course, if you graph it, it returns a graph. If it's linear, it's a line. If it's quadratic, it's going to be a parabola. So this is an example of a basic parabola because this equation is just negative x squared. And what do you notice about this parabola? How does it open? Downward. It's opening downward because?
Negative.
Which one is negative?
The x.
The x squared is negative. And we call this we always have a special names on each term, on each functions, and in this case, this is a quadratic term. So and how does it open? I mean, if the quadratic term is negative, the parabola is opening downwards. If the quadratic term is positive, how does it open?
Upward.
Upward. So it looks like a U-shaped graph. Let's say I have y equals 3 plus 2x minus x squared. How is this parabola going to open? I'm not asking you to solve it, but I'm just asking you how will this parabola open if we graph it?
Downward because of the negative x squared.
Yes, it's downward because of the negative x squared. So no matter where you place your x squared, as long as it's negative or positive, then you would know that it's going to go upward or downward. Now, are we going to graph this function right now? Not yet. But at least you know it's opening downwards, right? And that is, again, a skill on its own. Alright, so now that you know when it's opening and how it opens upward and downward, let's find the quadratic solution. Now, let's talk about solution. Because as I've mentioned, mathematics is like learning a foreign language. If you don't know the language or the words we're using, you'll get lost and you're just basically memorizing steps. And we know you're not learning if you're memorizing steps. Example, quadratic term. If I talk about quadratic term, you already know what I'm talking about, right? But if I talk or say quadratic term to a group of people who don't know what I'm talking about, they're probably lost about what quadratic term is. And if I say parabola, you know what a parabola I'm talking about, right? When we're talking about mathematics is the x-intercept of a function. Does it still sound foreign to you? X-intercept of a function. Do you have an idea now of what the solution is? To explain it to people who don't know mathematics, this is basically the zero. That is basically how you describe it. This is the word, this is the technical definition, and this is a description for people who don't know mathematics. Okay, let's say we have a parabola looking like this. And we know that the parabola, or the solution of a parabola, is the point of intersection of the graph on the x-axis. Do you know where the x-axis is in this xy plane? The horizontal line. This is your x-axis. Or technically, if we write it in an equation form, this is y equals 0. Because this is y equals 0, y equals 1, y equals 2, y equals 3, and so on, right? Now, how many solutions do you think we have in that parabola? I'll change the question. How many points of intersection do you think you have for this parabola that is touching the x-axis? None. Because it's possible that you can have no solution in a parabola. So this one has no solution. What about this parabola? How many solutions do you think we have in this parabola? And that is correct. We only have one solution because it's only touching the x-axis once on your, the graph is only touching the x-axis once in this equation. So again, you're not seeing an equation, you're not seeing a function, you're just seeing the graph of the parabola. But all of them are quadratics. What about this one? How many solutions do we think we have in this parabola? So these are the possible solutions that you can have in a parabola. Sometimes there's no solution. Sometimes there's one solution. Sometimes you'll have two solutions. Easy, right? It's easy if we're looking at a graph, because all functions can be graphed. And if you know the question in your math problem, you'll be able to understand it better. Let's make it a little bit more exciting. So we know what solutions are in algebra. We know how many solutions or possible solutions we'll have in a parabola or quadratic equation. This is a parabola, so we know it's a quadratic equation, right? This is the actual function of this parabola. And we know that it's true because the quadratic term is positive and the parabola is opening upward. We're not doing any algebra work. By just looking at the graph, can you solve the solution of x squared minus 4? Yes or no? Yes. How? By using the graph. And what do you see about the graph? And what do you know about the solution of the function? It is the point of intersection of the graph on the x-axis, right? Can you see where the point of intersection is by just looking at the graph? Where it's at?
-2 and at 4 for y, or
Negative 4 and? So you think this is also a solution?
maybe.
Kiani, what is the definition of the solution that we've talked about? A solution is what?
The x-intercept.
The x-intercept. So, is this intersecting the x? This is the y-intercept. So how many solutions do you think we have?
So we only have 2.
Yes, we only have 2. Easy, right? We don't even do mathematics or algebra work, but we're able to produce the solution because according to the definition, it's just the point of intersection of the graph on the x-axis. So we have -2 and 2. So we have 2 answers, 2 solutions. So it's easy if you're understanding the language of mathematics as opposed to memorizing steps, right? Let's have another example. Give me the solution. You're not doing anything, you're just looking at the graph. What are the solutions? First question, how many solutions do you think we have in this function? 2. Obviously it's 2 because you can see it, right? Now to be more specific, what are those 2 solutions?
0
and 2.
0 and 2. 1, 2. And that is correct because this is your x-axis, right? And it's crossing at x equal to 0 and x equal to 2. And you're done. You've answered the math problem that you are working on. Finding the solution, which is 0 and 2. So do you understand now what solutions are in mathematics? This is not just limited to quadratics. It could be this. It could be this. It could be that. And all of these functions, when they're asked to find the solution, it's just asking where the point of intersection of the graph is on the x-axis. However, we don't know what the graph of this look like yet. We don't know how this look like yet. We don't know how this look like yet. That's why mathematics is a skill, and the more you spend time in learning the language of mathematics, the better you become because you're more exposed to a lot of functions. But for today, we're just going to be concentrating on quadratics, all right? But at least you know or understand the whole rationale behind finding the solution of this equation. So you're understanding that every time you're asked to do that, you're finding the x-intercept of the graph. Now, find the solution. Is the graph given? No. So do you think this one is a little bit more difficult to solve than the previous 2 examples? Yes, because in mathematics, functions can be represented in a graph, and sometimes functions can be represented as an equation. And this is now an equation, and you're asked to find its solution. Now it's going to be a little bit more difficult because we don't see the graph. And if we don't see the graph, we'll use algebra. And that is why you need to know how to first know what you're looking for, why you're looking for it, and how are you looking for that particular answer in mathematics. And then if all else fails, probably we need to do a little bit of math. And that's what we're going to do next. We're going to be using algebra to solve for the solution because not all problems will be given in graph form. That's the sad reality of mathematics, just like life. It's not always going to be spoon-fed to us. Sometimes we really need to work hard to eat. Maybe we need to cook. Maybe we need to buy it somewhere else. Sometimes it's not always given to us. And now you need to work. Otherwise you'll go hungry. Or in this case, you'll go dumb. All right, whichever you prefer. So we're going to be working on the second part of our finding solution of a quadratic equation, factoring. Factoring is another method that we use for algebra so that we can find the solution without graphing it or without seeing the graph. That's why I've been reiterating this over and over again. You need to focus and you need to make sure that your factoring technique is spotless, so that you'll be able to enter a lot of functions in the process, because that's how it is, that's how math works. Okay, let's start it. Let's have the zero product. Hello everyone, this is Dr. Esperanza, and if you happen to like my video, please like, share, and hit that notification button and subscribe to my channel. Thank you.